Okay, hello, good morning. Um, so as you can probably hear already from my voice, I'm sick. I've been sick for a couple of days. But I've popped some pills. I got my snot wipes. I have a warm drink, so hopefully I don't cough too much. So we're just gonna try this, because even though like my brain keeps running, even though I'm feeling like shit. uh, So let's see here. So like we've been pivoting between like doing external state management, like looking at the specter of like on the one side you have mutable external state management, and then on the other end you have React itself. And then currently React isn't performant enough. That's why we have these state management libraries. Uh, and then there's a question like what happens? Oh, is there a comment there? What happens? Oh my god, that's too good. Um, it's a dear friend of mine who I've been having a few drinks with over the years. He thinks I've been out drinking. No, you have kids, you know what it's like. uh, that's too funny. Okay, so we've been looking at this spectrum, and then what I'm going to try to do during this stream is kind of just share these reflections, and then we're going to look at something that's I find very interesting. So where should we start? Where should we start? Okay, let's just start with the React part, because I've been like, I love using React, but I don't love using it for state management. It's not the primitives of React. It's it's that I have to do all this memoization, right? Use callback, use memo, all of this stuff. Have to consider a lot of things. So from one end, you can like try to fix that by giving React new primitives. So you're still in React, but you just give it new hooks and stuff like that. But very quickly, you can like break the mental model of React. And at the and eventually, it's like all about like just breaking. At the end of the day, it's about like trying to fix something that's very deep, technically a problem. It's not the APIs of React that's the problem, it's the underlying performance. Anyways, so what actually happens when we get the React compiler? Like, will it actually fix it? And there are two things that's going to happen with the React compiler. And that is, let's see. And by the way, I haven't prepared any of this, so you'll have to excuse me. There are two things that's going to happen. It's going to no use memo or use callback. And this is huge, because this means that you can just write your components using React as you would normally think you could use React, right? Learning about use memo and use callback is kind of a thing that you learn when you get deeper into React. You kind of get React as a mental model. But then, oh, by the way, you have to manually handle performance. Like you have to manually handle memory in like a lower level programming language, right? Nobody wants to do that when they're building freaking like web experiences. But that's going to be huge, right? But the other thing it fixes is, well, I guess we should add memo here as well, and memo. The other thing it's gonna fix is, well, I think we're gonna put that on the other side. And use callback, and then a waterfall reconciliation. Reconciliation memo. So on one end, it's automatically gonna convert like all these like floating objects and derived state and everything into use memo, any functions into use callback, just do it automatically. It doesn't matter how you define it. And then it's gonna go through and it's gonna fix waterfall reconciliation by adding memo to components. I'm not sure like exactly the strategy here. Is it gonna do it to everything? Is it gonna check the props and the likelihood? Like this is statically checked, right? So there's limits to what they can do here, but I at least that's kind of the thing is, it's not gonna make React 100% like optimal performance, but it's gonna be way better. Now, the biggest question for me has been context. So when you have like, let's see, you have like a context here. Sorry, I'm gonna zoom in a little bit, sorry. So you have context, and then you have like a component, a consumer, like some component nested in the tree. Like, the thing that the React compiler doesn't fix is that any state change that you make inside your context will make any consumer reconcile, right? That's not going to be fixed. And I was kind of hung up on that for a while. Like, yeah, React compiler, but it's not going to fix everything. But I'm kind of changing my perspective a bit. Like, through like all these explorations, I don't think we should try to fix React, which is like, duh, you shouldn't really try to fix it. One thing is creating a different way to do state management externally from React. That's more like a tool, right? But trying to fix React itself, that doesn't make any sense. Yeah, exactly. We did look at the React compiler output. So it does a lot of, it doesn't only cache, like, that's a good point, like no use memo and use callback, but it also optimizes like reusable pieces of JSX, right? So you have a lot of your components are static JSX or static elements, meaning you're not like using stuff from props or from state. It's static. So it also caches that. So the reconciler, when it reconciles, even uses less memory and I guess less CPU. Like less memory in the sense that you're not like recreating the node that you now have cached, and it can do like a very simple, it doesn't need to check it even, right? So I think that's a better way to explain it. It's like it's creating these cached static elements, kinda, that doesn't need to even go through the reconciler because they're always the same. Yeah, whatever. But it's a good point. So, but with context, even though it optimizes the hell out of this, like it even uses a memo on the value that you expose from context. Any change within the provider of this context, I should say context provider, any state change within this context provider will like break the memoization of the object that you're sharing, and every consumer will have to reconcile. But each consumer is also optimized by the React compiler. So it will have much less of a waterfall effect than what we're experiencing now. And a reflection I had is that if you remember back in the day, there was this concept of a higher order component where you would kind of manually expose props to, a component. Let's see. So what you could do is that you could have a higher order component that uses the context provider. And then what you do is you, how would this work? How would this work? Yeah, maybe this wouldn't work. Okay, I'm just gonna finish the thought. Like, I think there's at least an opportunity. I haven't thought about this a lot, but I think there's an opportunity to, you have, yeah, maybe not a higher order component, but what you at least can do, at least it's technically correct. So what you can do is that you can put like this, well, it is a wrapper, sorry. So this is a parent, but it's a parent component. It's not a higher order component, it's a parent component. And this parent component passes state down as props, right? So what happens then is that you have this like parent component that does nothing except like passing props down to the consumer and passing state from the context down to the consumer. So reconciling this parent component, there's no elements, nothing in there. It's like exceptionally cheap to reconcile it. And then the consumer is automatically memoized. So then you kind of get this like optimal app, like if you actually need it, right? So if you have a consumer that has a lot of like elements and stuff, and it's an expensive reconciliation, you can just create this parent component that's responsible, like a container component, I guess we used to call it back in the day, that passes the props and from the parent and the state from the context down as props. And then that consumer won't reconcile unless the specific state it consumed from the context actually changes or any of the props change. So with that in mind, I don't want to touch React anymore. I don't want to try to fix React. I don't think that makes sense. Because theoretically, if you want to fully embrace React, it seems like you can do that with the React compiler, even in like high demand, like complex state management, sharing a lot of state with a lot of components, you will be able to handle that just fine. But then the question is, maybe you don't like to do state management in React, right? It has its primitives that's bound to components and everything. So then you want to go external, and you might want to completely change the paradigm. Like here you have this like immutable mindset because you do value comparison. That's how the reconciler works. And that's why you have dependency arrays. It's to like figure out when to run the effects and when to break the memo cache and everything. So going external. So there are like two reasons for going external. One is you want a mutable paradigm. So this is why we use MobX, right? Also partly because it's like to have the absolute optimum performance in React, you want to have mutable observation. We can talk more about that, but that is technically the most optimized way of changing some piece of state and only affecting the components that actually rely on that state. But you might just want a different API, right? You just want a different API. So you don't like use state, and you don't like to be in yeah, I guess that's the third reason. You want escape the reconciler. So one thing is like, yeah, I guess they kind of tie into each other. So the reason that React has the API it has, like with use state and returning this tuple of the state and changing that state and stuff, it's because of the reconciler, right? And so partly maybe you don't like that way of, you don't like those APIs, or maybe you just don't like the fact of having a reconciler, doing your state management within a reconciler, like expressing everything in the function that's called again and again and again, right? So you're going external. And on the far edge of that external is a mutable state management tool. Because in between there, like going just on the boundary of external state management of React and to this edge of mutable state management, you have lots of different solutions like Redux, and they kind of still has this immutable mindset, or even like the reducer concept that's like in React and everything. And then you have like these atoms, and like they're also immutable, and there's so many ways to do state management, but very few of them actually provides you with a way to organize your state and scale it up, right? They focus very much on like, look at how easy it is to define some piece of state and use it in React. And they're solving a niche, right? But for me, state management is as much about organizing your state and knowing where to write your code, even not the state management itself. What about everything the state management is interacting with? That's just as important as like these primitives that you use to actually express the state and how you change that state. So so that's where I come from as well. Like I've worked on a couple of frameworks like Cerebral and Overmind, which are trying to give you this like mental model for how you organize your state, manage your side effects and everything. And they've been very valuable, like on the project I worked on and for other people. And also they've been very accessible, right? Because they have these like very strong concepts of like effect, state, and UI, like where do you put the stuff, right? But there is this other idea of, okay, what if we just use the language, right? What if we just use a single primitive to do external state management? And how would that primitive need to work to handle all that is state management? Okay, so that is what this like Bonsify thing is. It has like a primitive called reactive. And the only thing it does is that you give it an object and that thing becomes observable. And then there's a bubble or SWR, SWR. Oh, stay while revalidate SWC plugin. Yeah, that just makes all components observers and they're all memoed as well. So now you're in this mutable, observable paradigm where you are able to have like the absolute optimal performance out of the box, like what's it called? Like pinpointed state change, the actual components looking at that piece of state will reconcile. And also where it makes sense, right? Because if you have, depend on immutability, what often happens is that you have this list of items, right? And then when you change an item, that item is gonna change its reference, but the list is also gonna change its reference. So then the list component reconciles, your item component reconciles. But the thing about mutable state is that you can change a single property on that item. And if that item has a component, a nested component that actually uses that property, only that component is going to reconcile. So you see how this has to do with complexity. So as opposed to changing that single property of an item, the list reconciles and the full item reconciles, right? And the component that actually uses that property. Now only the component that uses that property reconciles. So that's where you get like the performance or like the pinpointed reconciliation from. Yes, but there are certain things. So maybe I can try to write some code here. So you have like state reactive and you have this object, right? So what Bonsify does, it doesn't give you any abstractions for organizing your state. It rather documents patterns that you can apply to any programming really. But it shows you how to like use the language to organize and encapsulate state. But there are certain things you can't do here. So, but before going into that, there's one thing that this needs to fix. When you have mutable state, by default, anything pointing to this state, any component, anything can just change the state and it's gonna do like, everything's gonna update. So you're not able to protect it. Now, the thing that MobX did to handle this is that they locked everything down by default, so you can't change anything. And then you would do like, maybe you have a count here. Maybe we should use VS Code here instead. Anyways, let's just do it. And then you have increase, right? And then you want to say like state.count plus plus. So by default, you can't do this with MobX, right? And the way they solved this is that they created something called an action, which I would, like, it makes a lot of sense. It's very an intuitive reaction to protecting state. Let's just lock everything down and let's pinpoint where you can change that state by using this action. The problem is that if this is async and you await something, now suddenly you can't do this state change anymore because this action requires synchronous handling, right? So now you have to put an action, run action or something. Like it gets very verbose, or you have to use this like new flow thing, which is like a generator. And it just gets icky. So the point is that you just want to change the thing, right? So the way Bonsify handles this is that when you actually expose your state to components or to other parts of your state management, you can do a return reactive read-only state. So now the internal scope, anything that has access to this reference, is allowed to mutate the state. But when you return a reactive read-only, that reference can't change the state. So now you can do whatever you want with your functions. It doesn't matter because it's about the reference you're pointing to, right? So I think this is a much better way to handle it, and I had to handle it this way. And it's a good example of how constraints can lead to better experiences. Because my constraint was I can only have one primitive. I wasn't allowed to have an action because I could only have reactive. So it kind of forced me to rethink this, and I think the result is better. Yeah, you can argue that read only is a primitive, but it's not really doing anything. It's not creating or giving features. It's just changing the mode of the object. So I'm kind of excusing that one. Anyways, so, but that's one thing, right? Read only. But then there are a couple of other concepts. You have something called effects or auto run or whatever you want to call it. And you have computed or derived. And let's put this in the excuse me. So you have something called effects. And so how was I gonna like solve this one? And the surprising answer was like, you shouldn't do it. You shouldn't have effects in your state management. And the reason I came to that conclusion is because at Code Sandbox in the version 2 editor, we embraced React and this pattern of using reducers for state management. But instead of like having functions that you call, which would dispatch changes into the reducer and then running like async logic there, we would only dispatch into the reducer. And the reducer would have like these explicit states transitioning. And then, and then on the outside, we would listen, like we would use effects to listen to these transitions and then run the effects. So it was very much a state machine concept where I learned like what I actually like about state machines and what I hate about state machines. And what I hate about state machines is the indirection of what actually happens when you transition between these states. You want to read that with the actual state transition. So that indirection is really, really bad. It makes it very hard to reason about code. And one thing is in React, right? You have use effect in React, but what is use effect actually designed for? It's not designed for you make a state change and then you make another state change. It's designed for subscriptions, right? So an effect is really about external change that leads to a state change. That's what an effect is. But with the concept I just talked about, using a reducer to do a state transition to run an effect, that would be like state change, external change. That's another way to look at it. And then you have the last one, which is like, so here we made a state change and then we performed like some effect from that. And the last one is you have a state change, and then you just make another state change, right? You're looking at a state change, and then you make a state change. So a very simple example of this would be you are doing, let's take our counter. So every time you change the count, you want to log that count, right? So you could use a use effect for that. So you can use effect, look at the count, and then console log that count, right? The problem is that it's completely disconnected from where you change the count. The most obvious way of doing it is just doing this. And that's how you should do it, because now the effect and the state change are locked together. You can see what happens when that state change is made, right? That's what you want in my experience. And then you can argue, oh, what if the count changes in different places? Well, then you just have to lift it, like increment and log, right? Then you have to do this. At every place you want to change the count, you have to call increment and log and pass the state, something like that. In my experience, that's not really an issue, but that's how you would solve it. And then, yes, maybe some place where you change the count, you forgot to call that function, right? That could happen. But the indirection issue is so much bigger of an issue. So the thing is, like, just don't do it. Don't do effects in state management. React has to do it for subscribing to external changes. That's how it kind of hooks into everything else. But especially state change for another state change, it's bad, in my book. Okay, and then we have computed or derived. So I'm gonna make another, again, like forced by these constraints. I'm taking the easy way out, and I'm saying you shouldn't. So one important thing when I say computed is that it's partly deriving state and partly caching that derived state. So that's what I mean, like cached derived. That's what I really mean. It's not deriving in and of itself, it's that you cache it. Which is complex in a reactive paradigm, because you need a subscription to listen to changes to whatever you're looking at. And that subscription needs to be disposed of, or you have a memory leak. So it's complex. So where was I? Yeah, so for example, if you want to derive something, of course you can do that, like double, and you say state.count, sorry, return, oh my God, return state, like this, right? So you can derive as much as you want. And but you shouldn't think about computed, like caching that derived state. You shouldn't think about caching at all. That's my statement. At least not be you shouldn't cache for the UI. That's what I mean. So if you look at like some state that's going to be consumed by the UI and you start worrying about the performance of the UI, then you're not in the right mindset. Another thing is like caching data, for example. So because you don't want to refetch on the server all the time. That's completely different. It's like, but computed is typically used to like help performance in the UI. It isn't to help performance in your state management or your server, right? So again, I'm just saying, and we're gonna get to like a resolution here, I promise. So yeah, don't do it. Don't cache derive. Okay, so you can still derive, but don't worry about caching it. Now, the interesting thing that was kind of the thing that I've been reflecting on for a couple of days, and I found a really clever solution to it. And that is when you have mutable state like Bonsify or MobX for that, or MobX or anything similar, you can combine them with the existing primitives of React. So you do use effect, you can't do use memo, because the dependency arrays are based on value comparison, right? So what happens? Well, the framework introduces special React hooks. That's exactly like use effect and exactly like use memo, only that it's based on observation, right? So you kind of now have duplicate sets of managing of effects and managing memo, and they don't overlap, right? So if you're using, so you would have, for example, use effect, use memo, and then you might have something called use reactive effect and use reactive memo, for example, which doesn't have a dependency array. The problem now is that you are going to be using React for some state, right? And then this other external solution for other state. But now you can't, like, they're not compatible, which is a huge mental burden, I think. What I did with Bonsify yesterday, I think, was to make this actually work. So you don't need these special things. So what you can do is that you can just build up your state externally. Don't worry about performance of the UI related to deriving. Never use effects. Like, you shouldn't do that for state management anyways. But then if you need to memoize anything, if you need to derive and memoize anything for the UI, just use React for it. And you can do that. Because even though Bonsify is mutable, it uses its proxies to, I don't want to say simulate, because it's technically like doing the same, but instead of changing the reference of the objects and arrays themselves, it changes it just removes the proxy, so that whenever you access that state again, it's going to create a new proxy, and that's going to be a different value in React's mind or in React's world. So maybe we could do like a proof of concept, or kind of show a demo of that. Do I have Bonsify here? I kind of hate that I have to click twice now to minimize. Kind of sucks. So I was going all down this route of like, oh, I'm going to add a data primitive and we need lookup records and everything. And it's just, I'm so glad, like, with all the experience I have, whenever I kind of get into a situation where I try to solve problems by creating new APIs, it's a smell for me. There's something I'm doing wrong. And without exception, I had them. Oh my god. I shouldn't have done this on camera. Sorry about that. I just watched myself and I felt like I was looking in the mirror. Sorry about that. Oh my god. Anyways. Let's see. Okay, so now Bonsify truly is just this single primitive where you can expose it as read-only. And then we have this interesting thing. And let's see if we can find... let me just build it. Let's see. Yeah. Whiskey. You know, it was kind of funny. I think it was around the time Mad Men was running on TV, and I kind of wanted to be... There's something... Like, one thing is the chauvinistic part of men in the 50s. I didn't want to be like that, but there's something about, like, wearing a suit and a hat and drinking whiskey at work. But I don't like whiskey. So for my birthday, my partner gave me, like, you know, the actual the crystal thing to put whiskey in and a whiskey glass. But then she bought iced tea. So I would like put iced tea in my like crystal whiskey bottle thing. Yeah. Let's see, where were we? Read demo. Let's run it. Okay. So what we're gonna play with is let's see, let's remove that. So let's just create like a counter here. Counter reactive. Oh, I'm not sure why it chooses like, probably because I'm linking it. Oh, sorry, not reactive, but Bonsify. Reactive. Oh yeah, let's. Oh, what did I do? Oh, classic. Return counter. Reactive. Sorry, reactive read only counter. Then we're gonna increase that counter. Okay, so let's just create that counter externally for now. And then let's remove a bunch of stuff here. Count, counter.count. And on click, counter.increase. Cool. Let's look at this amazing project. So we have our counter. Now, the thing is to be able to like demo this, to be able to like demo this, like we could, so like we could do a use effect here. And then we could do like counter count and then console log it. Like this, and this would work, right? Or shouldn't work at least. Yeah, so it logs every time. But the reason that works is because we're looking at a, what do you call them? Literal value. It's just a number, right? What we want to check is if this was part of an object or an array. Does it then actually change? So we're just going to nest this in nested, counter nested count, and then we're just going to pass nested, right? So we're passing the object. So in an immutable world, to change this nested count, we also would have to spread, right, on the nested. And we would also have to spread at the root. But now, hopefully this works. It would be so sad if this didn't work. You see that? It still works. And it's very interesting how this works. But the point of this, just to emphasize that, the point of this is that when you build up your state management, you can derive as much as you want, but don't derive to and cache it for UI performance reasons. Yeah, I have another point as well. So the point is to kind of just remove that concern from your state management. You're only about like managing your state, not thinking about UI at all and the performance of the UI. The components that's going to consume your state is going to be concerned about how efficient it is at consuming that state. So if it's deriving a ton of stuff to build up that UI, like that's why you derive. It's to bring state together to build a UI. And if that's a expensive computation, well, then memoize it. Just use memo. And another aspect of that is you wouldn't now, since you're not building state for the UI, you're not like building up this, like you're not even using computed in your state because you want to have performant UI. You rather build up your state management so that the UI can compose it together, because the UI knows what the shape of that state needs to be to most efficiently build the specific UI, right? Your state management doesn't know that or shouldn't know about that. It shouldn't really care about the UI at all. like that's another aspect of this. It's like, how can we break that spell of constantly being infected by UI concerns when building your external state management? And I think that like that's the theory behind this. It's like, okay, by enabling this, it's gonna break that spell. Maybe. But another even more important perspective is the React compiler. Because what's going to happen if, for example, you're using MobX or some other mutable observable? Yeah, I'm going to explain it, Adam. Be patient, be patient. But another important aspect of this, drink your beer. Another important aspect of this is the React compiler. Because if you're using external mutable state and you choose to use the React compiler, things are going to break. Because the React compiler can't see the difference between what's observable state or reactive state and what is just props, right? So it's going to start to memorize references from your external state management. But those, like, they don't change reference, right? That's the whole performance boost of mutable state. So I didn't think about that at all. It just hit me yesterday. Like I just did this because I wanted to break the spell of like UI influencing your state management. But I realized that, oh shit, this is really important if you want to use the React compiler. So kind of like how we've kind of put state management as concurrent safe, there's also going to be a wave of like React compiler safe. No worries, no worries. Yeah, so that's interesting to me. Like a lot of these external state management tools will work out of the box because they are immutable. They use immutable state, even if they're reactive. But some of them are mutable. Anyways, so how does this actually work? So it's really interesting. Let's get back to the drawing board. So let's imagine, how are we going to do this? Maybe I can do, okay, I'm going to use a syntax here. So, okay, let's see how I'm going to draw it. So we have this nested thing. We're just going to be concerned about the count. So this is how it looks like, right, when we read it. But under the hood, every object and every array has a proxy. So you have like object proxy. You have another object proxy here. Oh, sorry. Oh. Right? And by default, these proxies are mutable. Now, the thing that happens when you do reactive read-only is that you have a different set of proxies. Let's copy this. Sorry. Let's see. So now we have a read-only object proxy. Read-only object proxy. Okay. So that's how it works. And this is how MobX works as well, right? Every object and every array has its own proxy. The only thing that's different here is that we also have an additional proxy for read-only. Maybe there's yeah, it has to work that way. So I guess in that sense, Bonsify is using more memory. Well, like it's impossible to compare it, but isolated, it's using more proxies. I shouldn't say using more memory. It's just using more proxies. So this object proxy lives within your state management, and the read-only proxy lives typically in your component world. But this is the thing that protects it. Anyways, so the thing that happens when And what's important to understand is that proxies are objects themselves. So they have, the object proxy isn't equal to the object we're proxying. So if you compare, if you get a reference to the actual object you're proxying, and then your object proxy, and you do equal, they are not the same. So object proxies have their own reference, right? So when I started thinking about this, like, okay, how are we going to make these mutable changes be compatible with value comparison? I first thought I would actually have to make sure that when the count changes, I would have to walk up the proxy and then like recreate the objects, right? Basically doing what immer does. Like immer does what it's supposed to do. It's not like saying immer shouldn't do it the way it does it. It does exactly what it should do. But I thought I would have to do that. But what's happening now is that when you point down into the count here and you increase that count, there's logic there that triggers observation, right? But what it also does is that it has a list of all the how should I call it? The objects that was part of getting down to that count. So at the point of like handling the count change, it knows about all its parents, it being arrays or objects or whatever. Well, it can only be objects or arrays. It knows about them. And then it just says, hey, read only proxy cache, remove these proxies. So when the component reconciles again, it dives back into this object, right? And when it does that, it builds up new proxies, new read-only proxies that will have a new reference. So it basically does the exact same thing. It recreates the references, but it doesn't do it by like recreating the objects and arrays. It just does it by creating and getting rid of the old proxy that was bound to that object or array, and then recreates it. So the implementation is super, super simple. Yeah, because the other one will be much harder to implement, and like in terms of efficiency, that's hard to say, but it does less work, much less work, because it doesn't have to like spread changes into objects and spread into arrays to just change the reference of an array and stuff. So it's much more efficient in that sense. So that's kind of what happens. It's like every time you mutate at some point in the tree, it just obliterates all the read-only proxies as part of the path down to that point in the state. And then React reconciles, and it just lazily recreates those read-only proxies with new references, and memo and effect work. Cool. Oh, by the way, I think I have an appointment with just 2 seconds. Yeah, sorry. Okay, so that was like the technical thing, and then the thing to explore now is like, does it even make any sense? Yeah, I'm at least proud of how clever it is. But let's see how this affects an actual code base. That's the thing I was most excited about this stream. But it was nice to kind of, it's so funny how I just get like super mentally constipated, because I haven't streamed for 2 days, but I'm just thinking about stuff all the time. And when I sit down on the stream, everything just comes out. It's a very laxative experience for me. Okay, so we're back in our Bonsify version of Family Scrum, and now we have this concept of data. Let's see. I think we're just gonna start at the beginning. We don't need this terminal. So now we have the session thing. That's fine. Yeah. We're not doing anything special there. We're using this explicit states thing. And then we have Family Scrum, which... how are we doing this? Yeah, it's like the downside to mutable observable state is proxies. The amount of like actual memory overhead, like it's very hard to evaluate, right? Because what those extra proxies, on one end, the proxies in isolation just adds more overhead, right? Memory wise. And also, I guess, like to some degree, like accessing the properties and stuff, like it's literally a proxy, right? So there is a cost there. But comparing that to the amount of reconciliation you save, which is a huge memory waste, is very hard to evaluate, right? And then you can evaluate the developer experience. Like when you actually console log a proxy, it actually logs as a proxy, right? Even though you can access like the target object, it's not like the ideal thing, but everything's like you have to balance it. So in terms of like memory CPU thing, I think Mobex has shown that that's not a thing, or that's not a concern, at least not typically. And for developer experience, I guess it's also proven that it's worth the cost of having like proxy objects as opposed to like just pure objects. Yeah, but I wish Chrome would show them differently. I wish Chrome would show proxies as their target object, and then rather have like another, like it's about UI, right? It's not the developer experience of a proxy. That's not the problem. It's in the dev tool that shows the proxy. So Chrome could rather show the target object and then have an indicator that it's a proxy, right? Because you don't care about the proxy object itself. You just care about the target object being wrapped by a proxy. But yeah, it's an important question, like, or some important to evaluate. Let's see. But what are we doing here? We have groceries. Oh, we're not using data here. Okay, cool. But what do we want to do here? Now I have to now we have the problem of refactoring again. Like we refactored this so many times that I'm getting a bit exhausted. Let's see, groceries, but I'm not actually doing, yeah, I think I can just delete data. So now we have groceries here, and that's fine. One thing I was thinking of though is that I know we're gonna derive data. So what I'm wondering is if I want to try this pattern where we expose the data as records, and then Yeah, we're gonna do that. That's the simplest way of doing it, actually. So the reason you want data as arrays is because of UI. It's not because of state management. For state management, it's easier or more simpler to have your data as records because of the lookup. That's what you do in state management. You look up state, and you don't like to have an array and find stuff, right? You just want to do lookup. So we're going to do that, and then we're going to make that a concern for the UI to make the array, because it's the UI that wants the array. So we're kind of really forcing, breaking the, as I mentioned, the spell of being infected by UI mindset. Let's see. So groceries is going to be, where is the thingy? There we go. We're going to have a record of string grocery. And then we have a filter. Yeah, and the question here is like, what's this filter gonna be? Because I'm making the assumption now that I know that when you want to filter, that you want to filter on all the groceries. That might not be true. So what I'm gonna do, I'm gonna say that you need to pass in an array of groceries. And then I'm gonna filter on them and I'm gonna give it back to you. Yeah, this is gonna be interesting. Let's see. Or, you know, let's just assume that like there is no like specific filter. We will filter on everything, and we're going to return an array on that. Let's see. Let's see, groceries as grocery. So the only change here now is that we're still going to have this grocery abstraction, but we're not going to do this like we did last time. We had like one lookup record, and then we mapped it to like this other abstraction, and then we return it to the UI. We're just gonna, we're not gonna have the DTOs here. We're gonna have the actual like grocery entities, like as we can see here, to limit what can be done from the UI. But what we need to do is, what was it? Object from entries. I can't remember how this works. From entries, is it like data? No, how does this work? I can't remember. Object from entries, help me. Yeah, that's how it works. Oh, what did it do? Hey, what happened to my keyboard? There we go. Is this how you write it? This looks quite from entries. I felt like this was like when I got this suggestion last time. I typically do a reduce for this, but it has a typing issue. Yeah. But this is like, yeah, I'm not sure if I like this. So we're, I'm gonna do something else. We're gonna do create groceries. And then function create groceries. So the data here is a list of grocery DTO. And then we're not gonna have create grocery. Let's see. So I'm gonna do my little object, sorry. Data.reduce. Sorry. Accumulator grocery, I guess, DTO. And then we're gonna say grocery DTO.id equals I'm using data here as well. Grocery DTOs. Let's just do this instead. And then we call this data just to simplify. I don't have to change stuff again. And then this is the typing issue. But I think if I actually typed it, can I actually do the return type here? Record string grocery, does that work? No, that's the thing. I wish it was able to infer this, but I think if I put it on here, it works. Yeah, exactly. I think this is a simpler way of like reducing, you reduce an array to an object. Anyways, that's not the important part. We want to just have this object, and then here we are gonna object values, groceries. Yeah, now I don't need to slice it. Values, groceries, dot groceries, because that's gonna create the array. Okay, cool. So let's look at, sorry, I have to. Oh my God. So let's look at the actual groceries component now. Like, how would we actually consume it? Groceries. Yeah, so this one's interesting. So, is it actually able to run this now in Yarn Dev? That would be nice if it can actually run. I have so many Vite servers running. Log in with Google. That's me. Damn it. I have broken it. Where's this coming from? Fuck. Yeah, anyways. So let's just reason about it instead. So yeah, so the groceries is actually, it's always using the filter. But what, I really wanted to, maybe we can comment out this thing. See if we can do that. Current week calendar, the dashboard. Let's just. There we go. Let's see. Yeah, dashboard. Yeah, there's no groceries length now. So, okay, so this is interesting, right? So now we're gonna do a length of the groceries. So let's imagine like that was, imagine that I would now write count, groceries count, right? And I would do object.values family scrum groceries groceries.length, right? So if I had a React compiler activated, what would most likely happen here? I'm not sure. Like what would actually happen here? Okay, we're gonna test that. React compiler playground. Oh, it remembers what I did. Let's do, let's imagine we get family scrum here. Yeah. So what would it actually, yeah, so I guess it's wrong to say that it's like using memo and use callback. It does something more clever, but it kind of represents the thing. So let's do div count is groceries count. Let's see what actually happens here. So Uh, yeah, you can see it immediately. So if the groceries is not the same, yeah, if groceries is if groceries is not the same, it's gonna go and calculate this length, right? Object values. Yeah, so it's basically making the array itself. That's what it caches, and then it's checking the length. And what's gonna happen is that whenever I actually change, like I actually add, well, yeah, this is interesting. No, sorry. No, this is correct. So whenever, so this is, sorry. So groceries is an object, right? It is a record of the groceries. And for this UI, I want to check the length of it. So what I'm doing, I'm just going in, getting the values as an array to figure out the length, right? And what's going to happen is that it's going to cache that length. But if I were to add or remove a grocery from this record, this is going to be invalidated. It's going to change its reference. And that's going to re-evaluate this calculation, right? So this is the important thing. It's like we're relying on React for you to do UI, just write what you need for your UI. And then, because this is such a simple concern, it's like, okay, I need the UI needs the count of the groceries. Should I put that in my state management or should I not put it there? What should I put in my state management? Should I put the array in my state management, but let the groceries count the length, use the length of that array? So, and this is how you constantly evaluate when you have external state management. What should be in state management? What shouldn't be there? So what I'm trying to do now is like, no, the pattern for data is that you use records in your state management. Only use records. And then your UI needs to handle that record and convert it to whatever it needs to be. And then if you use the React compiler, that will automatically be optimized in the component. So what would happen here is that what would happen here is that if for some reason, well, for example, when you swipe the slides here, that's going to reconcile the whole component, but it's not going to recalculate the count for the groceries, right? Because that's been cached. So that's like, it's just efficient out of the box. Even, but in your code, you're just expressing what you want, and then you have this optimization. Yeah, exactly. It's very interesting how this actually works. So what I would have to do now without the React compiler is that I would have to do use memo like this. Family scrum groceries, right? And it even like autofills it correctly. Like it's just like these AIs are trained on a shit ton of React code. So this is what I will have to do now. But with the React compiler, that's just out of the question. Like, or you don't need to do that. You can just express the thing. And this is what I like. So two things I like. I think we're closer to breaking that influence of UI thinking when you do state management. And we get the benefits of the React compiler. And that's really cool. I like this. I really like this. Oh, sorry, I have to. Oh my God. Yeah, so maybe we can do a little bit more. I have a session with a colleague, but Let's see. Yeah, so we're gonna do this. This is the groceries count. Whoop. Now we have our groceries count. Nice. And if I go in here, hello. Add. Oh, look at that. Oh yeah, sorry, we didn't actually fix that component. Groceries. I think. Oh, why didn't we see any groceries? Did I break it? Wait, what happened there? Why didn't it actually store the... Hello? What did I do? What did I do? Why doesn't it store anything? But the weird thing is that it's almost like it's not storing it at all, because I'm not getting them here. Yeah, so that's a good question. So what would happen with MobX here? Well, I'm not sure if MobX actually does something like this internally, but I never heard of it. And they could do something like this, right? And maybe they will do when the React compiler becomes a thing. But by default, none of these, like the actual groceries object, won't change reference when we add and remove keys to it, right? So you have to explicitly make that reference different. So so yeah, by default, with mutable references, you would have a hard time with React and the React compiler. But yeah, I'm curious what we could test it. Like, what does MobX do when you change nested objects? Does it change the reference of the parents, or doesn't it? We could test that. I'm kind of bummed out that for some reason, maybe it identified it's not a valid. No. What the hell is happening to this thing? Is it not, why is it not storing it? Groceries API. And I'm not getting an error either. What did I do? What did I do? Subscribe all. Oh, does it even? Okay, I'm gonna check something. Grocery DTOs. Am I actually getting them? Oh, I am getting them. Oh, what did I do? Oh, sorry. I'm not. Oh my god, this is embarrassing. Yeah, sorry. Oh, you know what? Of course. Sorry, I was in a different mindset. This is what we're gonna do. There we have them. If this also means we'll reconcile when props are passed down. Oh, that's a good question. That's a very good question. I didn't think about that. So if you have nested state and you choose to pass a branch, well, okay. Yeah. So the answer is really no, but it's a really good question because these are two different mechanisms. One mechanism is the what should I call it? The notifier, like the notification of a change. Another thing is changing these references. So what would happen here is that when you have some nested state, yeah, you have some nested state, and then you're passing like a branch of state down to a component, right? So imagine, like, we can go back to the thingy. So wasn't it here I wrote it? Yeah, nested. So imagine you have a component that's consuming the root state, and then it passes down nested as a branch to some nested component. And that nested component looks at count. When that count is changed, the only component that gets notified about that change is the nested component that's actually looking at the count. But it will still change the reference of nested, right? So if the parent would reconcile related to something else, it would trigger a reconciliation of the nested component. So yeah, it does cause more reconciliation, or there's risk of more reconciliation, I guess. But nothing, not like more than React would do on its own. Yeah. So one thing is if it actually notified, oh, I changed the count. Oh, I changed nested. Like that would be a problem. Then it wouldn't have any benefits, right? But it doesn't do that. So it still has that surgical notification to components that actually observes. But again, if the parent component of nested would actually reconcile for some other reason, that one's really interesting. Yeah, exactly. Like you would kind of have to, yeah. It's an interesting one. I still think as a whole, it's more performant. I'm trying to think about scenarios. So imagine you have like a list of to-dos and you're flipping the completed of a to-do. And then it will reconcile only that single to-do component. And then maybe, okay, so let's imagine like you have the input of a new to-do also in the same component as the list itself. And then each item in the list, each to-do in the list is its own component. And then you flip the completed flag of a to-do, and that changes the reference of the actual to-do item, and it also changes the reference of the list of to-dos. And now, but nothing happens, right? It only when you flip the flag, it only reconciles that actual component. But when you start typing, you want to add a new to-do. Now it reconciles the parent, right? And it will reconcile the list again, which is fine. Like it has to do that. But for each to do in that list, it's not going to reconcile any other component because they haven't changed yet. But it is going to suddenly reconcile the one where you toggle the completed on, because now that suddenly has changed reference. Yeah. Yeah, it's interesting. Like you're kind of you kind of, yeah, and that like it's super hard to evaluate the impact of that. So normally, if you didn't do that, yeah. So normally, if you did like an immutable update on that, if you did an immutable update on that, it would reconcile immediately when you toggle. It would reconcile the parent, and it will reconcile that specific component. But now it would rather reconcile that component, and it would only do it once, right? At the moment when you toggle. But the change itself is more expensive because you're reconciling both the list and the item at the same time. But now you're just reconciling a component. But the cost is that when you do reconcile that list once again, it's also going to reconcile the component, the specific item. Yeah, exactly. Yeah, maybe it doesn't matter. Yeah, maybe. Well, ultimately, the point is that you want to do mutable state outside of React. So the whole point is that it shouldn't add to performance issues. But still, there's something about you, like we know, like reflecting on this, that when I toggle the completed state of that to do, it's in sync with its state, right? Yeah, that one's a tricky one. I'm not sure how I feel about that one. Like normally, like by default, it's much better that when you actually toggle that state, it does the reconciliation. It needs to get back in sync. But in a more complex, like when you have the example of the to-do item having a nested component that handles the toggle, for example, yeah, you kind of lose. Like you only gain the performance when the parent components doesn't need to reconcile. But and also there's like, so the prop itself, right? If that, if we could like keep the proxy reference on the prop, but that would break busting the proxy reference in the parent component for memoization and stuff. It would yeah, so if you, yeah, so again, like if you do the nested thing, so let's say that do component has like a nested component that does the completed toggle and consumes the completed state. When you toggle that and you go and like add a new to do on the text input, it would yeah, it would reconcile both components, the actual item and the toggle completed component. Yeah, so you're ending up with this. Well, you're not even, you actually end up with more reconciliation accumulated, but the first reconciliation is much more performant, right? That's the thing here. So you get a more performant reconciliation at the point of state update, but then you pay unknowingly amount when you make other state changes. Yeah. Damn it, Adam, why did you have to identify that? Uh, yeah. Yeah. Okay, so yeah, no, that would have to be the trade-off. But does it make sense? Does it actually make sense? Would it be better? Would it be better to yeah, but I need someone, like I create a lot of bubbles, so I need someone to burst them. Um, so you could say that instead of actually, like instead of just notifying a change to the actual count, it would notify changes to like all the parents as well, right? So you still have a mutable API, but it notifies change to all the parents. So what would happen then is that it would indeed just perform the same kind of reconciliation as it does. Yeah, so maybe that is a better model. Like, so to put that in context, normally, no, because you would have to do it all the way up. So it would be exactly the same. Oh. um yeah. So okay, so to put this in a different perspective, so what if it, so let's imagine it actually does notify every parent that it changed. What would happen is that it would act as if like you made this like it would behave the React way, right? But at the same time, you have this API where you're just mutating this object externally and you're just consuming it internally in React. And there's no like explicit consumption of the state. There's no like use store kind of thing where you subscribe explicitly to specific state you extract from the store and stuff like that. You're just passing this object into React and you just consume it. But it behaves exactly like as if you had, I wouldn't say context, because that's not true. But let's imagine, like you have this tree. Yeah, exactly. We're kind of fighting that flow. So a way to evaluate this is like, how many branches do you have in your state? Because the root state will never change its reference. There's no point in changing it, because you're passing that to the root component, right? So that it will never change. And then you pass, okay, so let's imagine an app where you have 5 pages and you have 5 state branches. One branch representing kind of the data that's needed and the state management that's needed within each page. And then you pass those branches down to each page. And then you make some nested change wherever, and that's going to cause a reconciliation from your router component first, because it's gonna create a pass like a new reference down to like page dashboard page, for example, and then that will like continue to reconcile. And I'm trying to reflect or find words to compare that to. So what if you just, okay, so what if you didn't have external state management? What if you just had a hook at the root, which represented these different branches? So you would have like 5 hooks representing these 5 different branches. And they're at the root component, and then you pass each branch down to each route representing these different pages. And then, well, one thing is, of course, well, no, that's fine. Okay, so you're doing that. And you're using the React compiler, so all of this stuff is like optimized. And then you have this nested change, and kind of the exact same thing happens. It's making the change in the root component, but it only changes reference of that single branch, and then that's passed down, and you kind of have this. It's a waterfall reconciliation, like top-down data flow, but of course it's optimized, so it only reconciles the things that's actually affected by it. So what are we left with then? What we're basically left with is just expressing state management outside of the reconciler using a mutable API and passing an object. So it won't be, especially compared to the React compiler, it's not about performance anymore, which it really shouldn't be. That's the whole point, right? Why, if React didn't have performance issues, would we still create these external state management libraries? Or is the only motivation performance? And I think the answer to that is yes, we would create external libraries, but it would be motivated by not being bound by the reconciler, and using React state management primitives bound by the reconciler, because it's tricky. It's just, or is it tricky? Like, how important is it to use a mutable object to express state changes compared to a function that has like multiple use states, and then you return an object that has these states and the functions for changing that state? And it's interesting because you wouldn't even need yeah, what's interesting is that you don't really need proxies either. Like, if the goal is, no, I just want to create these objects, well, yeah, you still need proxies because you need to know when you change them. But you wouldn't like notify the specific component anymore, right? You would just notify the root that something changed. And then you've already updated the references. This could still be based on proxies. So it would still have the same mechanism, but it wouldn't, okay, so to put it this way, you wouldn't use observers. It wouldn't have the plugin. Good question. Is the motivation, at least? It is the motivation. It's like not trying to fix React. It's trying to like, what is the real value of using external state management? What are we actually if there isn't performance issues, what is the real value of using external state management? Because if you have external state management that, oh my god, that works with a React compiler, then you don't have performance issues. So why do you do external state management? But what you can do is you can simplify. Like, don't create these like you don't need a bubble plugin because you don't have to make anything observers anymore. What you rather do is that you subscribe to the root object. Only thing you do is that you subscribe to the root object that you pass into React, which is all your state management. And then whenever that changes, you reconcile from the top. So it would simplify. Yeah, you don't need observation. Yeah, and why wouldn't you just pass the primitive value? It's because you can't predict it, like with a React compiler. You can't predict what it's going to reference. And it's an exception, right? In React, you don't have to be explicit about passing the primitive value. So it would be not compliant with how React works. So one thing that, so I think we're kind of in a distilling process, because now we're going to think about React as React with the compiler. And then we're distilling external state management down to its very core value, right? And what is that core value? And I think the core value is simply it's mutability using the mutation API. But you don't really need, I'm trying to think about how this works in the context of like immer. Well, yeah, so the thing is, like, the tricky thing to do there is you still need to know when things change. Yeah, so it's like to support a React compiler, because that's gonna be a thing. Everyone's gonna be using that, because it's gonna change the developer experience of React. It's gonna allow you to just write JavaScript in your components, and it does the caching for you. So you don't have to think about use callback or use memo or anything. It's just gonna work. Yeah, so the thing, like, we're talking about, like, when a change occurs, what happens, right? So we're saying now that when a change occurs, we're not going to notify the point of change, like where the state is consumed. We're just saying when the change happens, reconcile from the top. So that's kind of what we're saying now. And then where's the value, right? Because you're losing that optimization of only updating the component. And that's true. But what does that leave us with? Well, what it leaves us with is that you can make a change to any nested part of the tree, and it will reconcile from the top, right? You don't have to like, you can do a mutation at any part of the tree, and it will still reconcile from the top, which is not true for like a true immutable version, because then you would literally have to express all the changes you're making from the top. Like you have to spread all the changes down to the state you're actually changing. But now you can just point directly to, just like Immer, you just point directly to some piece of state in your state management. You change it, but it causes a reconciliation from the top with updated references. And you have the read-only aspect of this. So you actually get an error if you try to change the state. Yeah, it's interesting. But what I come to learn is like, I truly think the React compiler is gonna remove the whole argument of performance. But it's hard to say, right? What is the biggest reconciliation problem? Is it because you're not reconciling the specific component, that you're only reconciling a specific component that consumes a specific piece of state? Or is it just because when you make that change, so you have like 3 steps. You can reconcile the specific component. You can reconcile exactly the component tree that consumes the path down to that value, right? Or you can or you can reconcile a bunch of unrelated components because you haven't memoized properly, right? So that's the challenge for me. It's like the React compiler ensures that you actually reconcile only the parts that kind of needs to look at the changed path down to the value. And that might be good enough. Because the real cost and problem is that it also reconciles so many other things that's completely unrelated to that value you changed. Yeah. Oh, this is very interesting. This is definitely one to reflect on. Because what I feel we're left with is just yeah, because I think to some extent if you had like yeah, to some extent if you just had Immer combined with uState, like yeah, it's just a bit more boilerplate, right? It's with uState you have to use a callback to update the state. You can't just point to like an object. Like it's a pretty bad experience. Just writing that code, you feel like you're writing more boilerplate than actual value, right? That's what's so enjoyable about MobX and these reactive state mutable solutions is that you're literally writing code that gives value. There's no boilerplate to it at all. While in React, there's a shit ton of boilerplate. Like you need Immer to do like nested updates and stuff like that. Yeah, so and you could even argue that it would actually be more efficient to do it in React because if you do it externally, you have to notify a change up to the root, right? But if you were to implement the state in React, then you would rather put the state, like the page state we talked about, you would put that maybe even on the page itself. Like you wouldn't put it at the root, you would put it closer. So that means that it only reconciles from that point instead of from the root every time. Not that it would like matter, but like theoretically. So it's almost like if you in that world, if you wanted to just do let's see, you could just const let's see, yeah, some state, and you say like use, not even call it reactive, like use store or something, I don't know, then count 0, and then so this would be like a hook, and you would return that state, or you would even, yeah, you would even do something like this, right? So you return the state and then like increase. And that's fine to do now. And then you could still do this state.count. So this, so you have a single use, so you have a use state that, so instead of use state, you return a proxy so that you can just more expressively change state. You don't need a boilerplate and all of that. And whenever you point to state, you'll always get the latest value, right? But you can still spread it here. That's perfectly fine, because whenever you change this state, it will reconcile this. And what would happen here is that, yeah, I wonder what it would do here. The compiler. It would do something similar. So, yeah, let's make this a hook. Use counter, use counter. Oops. Function, use counter. Oh, interesting, doesn't it? To do support function with unreachable code that may contain hoisted declarations. Interesting. It doesn't support that pattern. Oh, interesting. Oh, look at this. They're actually detecting that. Yeah, so that wouldn't actually work. That's so interesting. But at least in theory, yeah, that's very interesting. Okay, you know, I'm gonna stop the stream. I need to think about this. But the whole point there is to just distill. Like, what do we need external state management for? What's the actual value of it? And to me now, it seems like the actual value is how you are able to express changes to the state. And the question then becomes, like, it's not a performance issue anymore with the React compiler, but it becomes more an issue of how you express it. Because here you would have to do like, but yeah, maybe it's fine. So a better example would be, okay, you have an array, list, set list. But again, you can just do, yeah, it's interesting. Like, how does it, so set list current, I think this would also break, right? Current list.push foo. Oh, so it doesn't do it there. Interesting. Okay. Because what you want to do is like list push foo. Oh, why does it support that? Mutating a value, but this is also mutating a value. That's interesting. That is interesting. Um, no, I need to think of this. It started off as like every time I think I have like, oh yeah, this is great, this is the solution. But like every time we also get a little bit closer to what is an ideal solution, in my mind at least. But also very interesting identifying the dynamic between optimally reconciling a state change using observation versus the need for like computed like memoizing and using effects. Yeah. No, anyways, I'm not gonna get any further. Thanks for all the input. That was awesome. And have a great weekend. Bye bye.